Hello, welcome to lesson 36. Yes, this is a typo, so make sure to change that in your notes. This is lesson 36. We will be covering section 5.1 from the textbook about line fitting. So you are encouraged to read pages 221 to 227 from the textbook. A scatterplot is a useful summary between two numerical variables. It gives a good visual picture of the relationship between the two variables and aids the interpretation of the correlation coefficient or regression model. It is important to determine which of the two numerical variables goes on the x-axis and which on the y-axis. When the roles are clear, the explanatory variable goes on the x-axis and the response variable goes on the y-axis. So in this example, we can see a graph with explanatory across the bottom and response up the side. Here's example 1. Pick out which variable you think should be the explanatory, or x, and which variable should be the response, or y. You have data on the circumference of oak trees measured 12 inches from the ground and their age in years. An oak tree in the park has a circumference of 36 inches, and you wish to know approximately how old it is. So we know the circumference and we want to predict the age. The thing that we are trying to predict is the response variable. So the circumference is the explanatory and the age is the response. So when describing a scatter plot, there are 4 things to consider. The first one is direction, the second one is form, the third one is strength, and the last one is outliers. Let's first talk about direction. Positive correlation means that both variables are generally increasing or decreasing at the same time. Negative correlation, as one variable increases, the other generally decreases. No correlation means the direction is either not clear or not linear. So here's an example of positive correlation, here's an example of negative correlation, and here's an example of no correlation. Next, let's talk about form. Linear form means the graph appears to stretch out in a generally consistent straight form. Nonlinear means the graph appears to show a curve up and down, for example. So this is an example of linear. This is an example of nonlinear. In this course, we will only consider fitting linear models to our data. If our data shows a nonlinear form, then more advanced techniques should be used. Next, let's talk about strength. So strong means the points appear to follow a single stream, whether straight, curved, or bending all over the place. Weak means the points appear as a vague cloud with no discernible pattern or trend. So here's our scale from strong all the way to none. So we have moderate, weak, and then none. So this would be an example of no strength, and this would be an example of strong strength. Last, we'll talk about outliers. So look for the unexpected. Outliers can offer valuable insight, but can also completely distort your analysis. Fortunately, potential outliers can be easily identified with the graph. So this guy over here would be an outlier. Without the outlier, we have a very strong nonlinear graph because it kind of curves a little bit. Here's example 2. Describe the direction, form, strength, and any unusual features in the scatter plot. Okay, so let's start with direction. Looks like the direction is positive. As the husband's age increases, so does the wife's age. The form looks to be linear. It looks like it's following a straight line. Strength, I would say that looks pretty strong to me, strong linear. Unusual features, like outliers, I would say probably none. Now, we could argue maybe this point is a little far away, but it doesn't seem to be too far away. So I don't know if I would count that as an outlier. The x-axis is the explanatory variable, and the y-axis is the response variable. Here's example 3. Below is a scatter plot of a person's performance IQ plotted against their brain size. Describe the direction, form, strength, and any unusual features in the scatter plot. Okay, let's start with direction. So maybe it's slightly positive only because there's no data points down here in the lower right corner. The form, I would say that the form is nonlinear. I don't see this data following a straight line. Strength, I don't see it following any type of line, so I would say very weak. Unusual features. I don't see any evidence of outliers. I wouldn't know how to tell one anyway because everything's so scattered, so I don't know. And so the x-axis here is the explanatory variable, and the y-axis here is the response variable. So what happened was some researcher tried to predict performance IQ by measuring their person's brain size. So as you can see, the results were that there is no correlation there. Here's example 4. Below is a scatter plot of the maximum wind speed in miles per hour plotted against the central pressure in MB for 163 hurricanes that have hit the United States since 1851. Describe the direction, form, strength, and any unusual features in the scatter plot. Okay, so let's start with direction. This would be a negative direction because as the central pressure increases, the maximum wind speed decreases. The form, I would say that this is pretty linear. Looks like it's following a generally straight line. The strength, I would say strong. Some people might say moderate there. Unusual features. So any outliers? Maybe we could describe these two as a couple of outliers. So maybe a couple of outliers. I would say that they probably don't have a strong impact. And the reason I say probably not a strong impact is because our sample size is 163. So measuring 163 hurricanes is a large sample. So outliers don't affect large samples very much. So the explanatory variable is here across the bottom, and it's used to predict the wind speed, which is the response variable. Here's example 5. Each of the 2025 elementary schools in Ohio are plotted below. Comparing the passing rate on the state's 4th grade reading proficiency test with the school's poverty level, describe the direction, form, strength, and any unusual features in the scatter plot. Okay, so let's start with direction. This looks like a negative direction because as the percentage of students eligible for free and reduced price lunches increases, the percentage of students who passed reading proficiency tests in March 2000 decreases. The form, this looks linear. Doesn't look like it's following a curve at all. The strength, so this time I would probably say this is moderate or strong. It's a very, very large sample. So sometimes it's harder to see the strength of it. So if we were to zoom out, for example, on this picture, it would probably look a lot more strong. Unusual features. So it does look like there's a couple of outliers, possibly, but this may not affect the data because the sample is so large. Okay, so once again we have the explanatory here across the bottom. And so right here, these are the people that have low passing rates with high poverty. And over here we have the response. And so up here in this corner we have high passing rates with low poverty.